Let's have a look at the 2018 question on area and volume chapter. So, when she's on holidays, Barbara sees the building shown on the right. She wants to estimate the surface area of one of the spheres of the building. She estimates that the radius of this sphere is 9 meters. Using Barbara's estimate for the radius, work out her estimate of the surface area of the sphere. Give your answer in terms of pi. Okay, so the first thing is its surface area. And surface area is all about a 3D shape. So you can see those spheres are not a flat circle where you just work out an area being equal to pi r squared. It's actually a 3D shape, so it's a sphere. So surface area then is literally the area of all of the edges of that sphere. So you can see, think of a football. It's as if you were going to cover that football with wrapping paper, and then how much wrapping paper would you need? What surface area has it? So surface area, volume, they're all done on 3D shapes. Okay, so surface area then, I don't use area, normal area here. That applies a 2D shape. I'm here on page 8 of your log tables, surface area and volume. And you can see it tells you in the following, A represents the curved surface area and V represents the volume. So I come to my shape, a sphere, which is this one, and I know this A formula here is my curved surface area. This would be my volume, but this is my curved surface area. So 4 pi r squared is what I'm getting for that. So my curved surface area is 4 pi r squared. Well, 4 is just a number, pi is just a number, and r is the only thing we can sub in. And the radius, r is for radius of this sphere, is 9 squared. Okay? And if we put that into the calculator, we are getting 324 pi. Don't forget your units. So it's meters squared, because it's still area, so it's meters squared. Okay, so that's it in terms of pi. It's not the same as 324, because if you sub in the value for pi, wouldn't it be 3.14? So if you S to D your answer, you'll see that you get 1017.876, okay? So you can see now that that number is not 324. 324 pi is 1017, okay? So the reason they leave pi in the answer is because there's no rounding. So in some cases, the next part of the question would have pi's cancelling and so on and so forth. So in some cases, they tend to leave pi in the answer. So the surface area of that sphere, according to Barbara's estimate, is 324 pi. Okay, so we have 324 pi for Barbara's estimate. Work out the actual radius of this sphere is between 8 meters and 10 meters inclusive. Work out the maximum value of the percentage error in Barbara's estimate of the surface area of the sphere, i.e. the error as a percentage of the actual surface area. Okay, so when you're getting percentage anything, so percentage error, it is difference over the true value. Okay, and you normally multiply it by 100 to convert it to a percentage. Okay, and this formula, it's a bit of a generic formula, but it works for percentage profit, percentage loss, percentage errors, percentage anything really. Okay, so work out the maximum value of the percentage error. Okay, so how I would do this one is I would go right. So the Barbara took it to be 9, the radius to be 9, okay? So the furthest away from 9 is either 10 or 8. Okay, so they're going to be the worst case numbers for working out the error. Okay, so we'll say the radius was 8 meters. Okay, then my curved surface area is still 4 pi r squared. So it's 4 pi 8 squared. So I'm putting that into the calculator, 4 pi by 8 squared, and I'm getting 256 pi. Okay, so the error, if the true value was 8, would be 324 pi minus 256 pi. And it's 68 pi. Okay, so then the percentage error, yeah, it's percentage error. So the difference over the true value, and we're pretending the true value for this one is 8. So therefore the true surface area would be 256, and multiply it by 100 or 100 over 1 to convert it to a percentage. So 68 pi over 256 pi, multiply by 100, and I am getting 26.56 percentage error in that one. Okay, and you can see that if the radius is bigger, so we'll say it's 8.1 or it's 8.2, then I'm going to be closer to Barbara's estimate of 9. So therefore my percentage error is going to be less. Okay, so this is the worst case on the minimum side. Okay, I'm not done yet because it could also be higher, and the very highest it can be is 10. So let's work out our curved surface area here. And that's 400 pi. Okay, so the error, if the true value is bigger, is 400 pi minus 324 pi. And it's 76 pi. So look at this. This is a bigger error. Okay, so I have 76 pi over the true value multiplied by 100 over 1. So let's try that one. So 76 over 400 multiplied by 100, and I'm just getting 19%. Okay, why less? So although the value was bigger, my percentage is less. And that's because it was a bigger error, all right, but it was over a bigger number. So as a percentage, it ends up being smaller. So the safest thing would have been to do both. That's what I think I would have done when I was in junior cert. And then therefore, the max error equals, give your answer correct to the nearest percent, 27%. Okay, try and remember this formula because it'll get you out of bother in a lot of cases if you can apply it to your question.